And so I'm just going to backtrack a little bit, right, on page 30, right? So we're going to graph systems. So you're going to have 2 or more inequalities. So I'm going to start nice and easy, 2 first. And then more than 3, it's less likely to happen, okay? 3 is going to be kind of like the top. If there are 4, I'll show you that it'll be with easier cases. But 3, you should be able to do 3 for sure, okay? So I give you some weird notation here. We just focused on the inequalities themselves. We worked with them separately, right? Separately, we went through everything. And please tell yourself this, okay? I strongly encourage you to, at the end, before you graph, you tell yourself where the true region is and you tell yourself where you're going to shade. And let's say you make a mistake, which is, it's likely that you will make a mistake, okay? Maybe not every single question, but at some point we missed a sign or something, you don't flip it. I'm going to go by what you tell me here. So this test is a nightmare to mark, okay? Because if you get anything wrong, your graph is completely different, but I honor it, right? I'm like, okay, you lose a mark here for getting this wrong, let's say. But then I'm going to go with what you're doing. I'm going to have Desmos open, right? I type in what you got, and then I will check, is your graph actually what it's supposed to be, even though you made a mistake, right? So I'm going to follow through and just make sure you're consistent throughout, right? Even if it looks wrong, well, if it looks wrong, you should probably go check back, right? And one way to check is, is your y-intercept the same as when you rewrite it, right? -2, -2, check, right? So how about we do that? Right? Just going to do that, right? +3, +3. So you're like, hey, I'm on the right track. I'm doing something right here because it adds up, right? So it jives. That's what you want. And then you tell yourself this, right? Dashed versus solid. Where is the true region? It happens to be in the same, right? Both of them are below. So therefore, both of the shadings should be the same. You should be shading above because we're doing reverse shading. Okay. All right. Now let's go on to graphing. But before you do that, before you graph, enter IQs into calculator. Okay, so you go like this. So we're going to do that right now. I'm going to treat this as equations. These two here, I'm going to enter them into the calculator. Turn off plot 1 because you're not going to do a regression because that often messes with the equation and you get an error. Okay, so how about I put this one in first? So brackets 4 divided by 6, bracket x minus 2. Then I go to the next one, bracket -2 over 3 x plus 3. They actually both have the same slope. I don't know if you, and numerically speaking, right? If you simplify 4 over 6, it's also 2 over 3. But notice that one is negative and one is positive, right? So hit graph. I'm going to do a zoom standard. I'm not going to hit graph because my window is going to be off. I was doing grade 12 applied stuff, right? So zoom 6. Usually when it's, unless it's a word problem, a standard window will at least get you started, and then you might have to adjust. But when you press zoom standard, what window are we looking at? We're looking at a -10 to 10, -10 to 10. So right now I'm seeing all intercepts and I'm seeing the point of intersection with this window. That tells you that if you transfer it over to this, your point of intersection is going to make it, right? Because sometimes what happens is, sorry, this is all I've got. But sometimes, let's say 2 lines, you graph them, right? and the point of intersection happens to be like way out here, you don't want that. You want it to fit on your graph. And so you're going to have to adjust your scale slightly to make that happen. And you're like, how? I will show you down the road how that works. But now you know when you enter it, you're like, okay, this is what I'm expecting to see, right? So let's go ahead and just graph it. So arrowheads on the axes, X, Y, and I'm just going to go 5, 10. It's going to work for me. -5, 10. I will tell you this. If your scale is 1, you don't need to label it. But I still do. It takes seconds, right? Okay, so there's your grid. And let's go ahead and graph. I'm going to do the first one here. I have 3, 0, 0, -2. So 3 zeros right there. 0, -2 is there. Remember, x-intercept, y-intercept, right? X-intercept, y-intercept. So you grab your ruler. No hand bombing, okay, guys? None of this. Then now we're talking cubic or some other function, right? It has to be linear. Okay, use your credit card. Oh, you don't have credit cards, never mind. So that one I'm telling myself is dashed. So I'm just going to go like this, line them up. I'm going to look for everything, guys. I'm going to take my time, right? So don't risk it. 4x minus 6y is greater than 12. So I'm writing the equation down so I don't forget, I don't mix them up. Don't do it in the middle. Use the ends, right? And I usually go well past, right? I almost go outside the graph if I need to, but I know that my point of intersection is somewhere here, right? Based on my calculator. So the next one is 4.5. So I'm going to go 4.5. That's right there. Just make a nice dot. And it's 0, 3. Right? I'm expecting it to go down because it has a negative slope, right? So it should always jive. And that is a solid line, right? That is solid. And I'm going to go and write the equation 2x plus 3y is less than or equal to 9. Put it way at the top. How come you didn't shade right away? I tend to leave the shading for once I've graphed it all. Okay. Oh, I made a mistake, right? Oops. So this line is supposed to cross there, not there. And why did I notice that? Because on my calculator, it's not on the x-axis, right? So I need to redo this. Sorry, my bad. And I was going to give you a tip not to press too hard on while you're making your lines, and I just completely ignored it. But anyways, I was too confident. So there's the point, right, that I'm crossing, 4.5 and that. So I'm going to make sure I line those up. Still a solid line, right? There you go. And the inequality is still close enough to it. POI is very important to us, right? That there's going to be we're going to label that shortly. And so let's shade. So the very first one, I'm supposed to shade above the line, correct? So you go on it. And just lightly, okay? It doesn't have to be. And then see now why I also shade at the end? If you make a mistake on your lines, right, you don't need to erase all that shading and all that. So there's that one. And the other one is also shading above. So you go to the next line. And now you shade along that one. Kind of just go like this. So you see that there's two patterns kind of crossing. So once you're done, because we used reverse shading, what is left, what is not shaded, is our solution region. Okay. And this is our POI, so we're going to figure that out. So you grab your calculator, second trace 5, and because there's only 2 lines, you just hit enter 3 times. And it is 3.75, 0.5. And it actually is quite accurate because we're using a grid, right? We're actually using a grid, even if you just don't, but don't read it off your graph. Use your calculator to find the exact point. Right? So I'm just going to write it down here. Second trace 5, right? The point of intersection. I'm going to ask you later on to actually state it on the side. You don't have to label it on here, but it's important to us for this right now, for this example. Make sure that stands out. Okay. Okay. So now the question says, is the point 4,5 a solution to the system? Obviously, but by the graph, right, 4, 5 would be somewhere in here, right, up here. And you know it's not, right? Graphically speaking, anything that's in the shaded region is not going to be a solution. But you will show your work in this case because likely is that I'm not going to ask you to graph it to figure this one out. So what you do is sub into both inequalities. Stop as soon as one is false. It sounds wrong, but I'll just put it like that. If you notice one you enter it and it's false, done. You don't need to keep entering into the other inequalities because it needs to be true for all of them. So as soon as it's not true, you stop. So inequality 1, we're going to substitute that into that one. And that was 4 times 4 minus 6 times 5. And that is greater than 12. So that's 16 minus 30 is supposed to be greater than 12. And this gives you negative 14 is greater than 12. This is false. Therefore, not a solution. I did not enter it into the other one, did I? It could have been true for that one, but it actually it won't because it's going to be false for both. But as soon as one of them is false, you stop. But if it's true, then you would have continued to try until, if it's actually true for all of them, then so a possible solution would have been, let's say 5, negative 5, right, would definitely be a possible solution. Let's put that down. A possible solution. Example 5, negative 5. You could have done 10, negative 100, right? 10, negative 100 is like way down here. way down there somewhere, but you know it's going to be in the non-shaded region, right? And there's more examples that you could have picked. Question is, would that point, the POI, actually be a solution to the system? Because it's on both lines, correct? It would be for this one because this is solid, but this one is dashed, so it wouldn't be. But it's still important for you to find that point. More about that later. Okay, let's try another one. And after that, I'll give you some time to try some on your own. I want to see if there's a tricky one. Yeah, I'm going to do the tricky one. So I'm going to skip 31. Just remember, does that look familiar to you? This is on 31. Sorry, I'm going to skip it, but I just want to give you a heads up because I'm going to ask you to do it. What kind of line would that be? That's a special case. It's just a vertical line. Like there's no x-intercepts, no y-intercept. You don't need to find anything. You actually are happy to see something like that. It's very easy to graph, right? And then you're going to have to compare it to that one. So I'll let you do that one. But let's do the tricky one together here. Page 32. I'm thinking if I should let you try one right away first. What do you think? Not ready yet? Okay. Let's do one more here. X plus 2y is less than 6. So I'm going to find the x-intercept, y-intercept. And it shouldn't, after a while when you practice these, it shouldn't take you that long, okay? If y is equal to 0, x is just equal to 6, you're done. If x is equal to 0, it's 2y is equal to 6. Divide both by 2, y is equal to 3. 0, 3. That's how quick you should figure this out after a while. Then I rewrite it. Notice that it is the way I like it to be, and this is called standard form. When you have, you can't see that properly, can you? When you have both variables on the left side and a constant on the other side. So I make it look like that if it's not like it at the beginning. Okay, I do some work to it. And then so 2y is less than negative x plus 6. So I immediately start rewriting it. I divide both sides by 2. Y is less than negative 1/2 x, right? Negative 1/2 x plus 3. And that jives with what I got before, so I'm happy about that. This is going to be a dashed line. The true region, that is the most important part to figure out where's the true region. The true region is below, right? And since this is a system, I'm going to shade the opposite. I'm going to shade above because I'm using reverse shading. How do you know you're using reverse shading, Mr. Dirksen? Because it's a system. For sure, I like to use reverse if it's a system. And then the one that will throw you for a loop. Okay, something like that. It's going to throw you for a loop. So I'm going to show you how I approach this. I will bring the y over to the other side. Watch. X minus y is less than what's left on the right side. Nothing, right? 0. You brought the y over. So you can also think of it that way. And this is what's going to throw you off. X-intercept, y-intercept. Can you already tell what the intercepts are going to be? 0, 0 for both of them. Because if y is equal to 0, you end up with that, which is 0, 0. And if you let x equal to 0 on the other side, it's negative y is equal to 0. You can divide both of them by negative 1 if you'd like. But it's still 0. So 0, 0. So this tells you it goes through the origin. This line goes through the origin. And you don't have 2 points, do you? You don't have 2 distinct points. It's like 1 point 0, 0 and another 1, 0, 0. You can't make a line, right? So you need to be creative. Goes through origin. Okay? And with this case, you need a second point. Okay? You need a second point to make your graph. So watch what I do here. Rewrite. So I will rewrite it. So it's negative y is less than negative x. You divide both sides by negative 1. So I think you're so used to having a bunch of stuff going on that this may seem almost counterintuitive, but you do the same thing as before, right? Divide both sides by negative 1. So it's really y. What happens to the inequality? You flip it. Y is greater than x. So what you do here is you let x be something. Let x be equal to, what would you like it to be? I'm just randomly thinking 4. You want 5? 5, 6, 7? It doesn't matter. But when x is equal to 4, what do we know y is going to be equal to? You're looking at the y equals x line. Think of y is equal to x because that's the boundary line. This is the boundary for this inequality, correct? We just put an equal sign in there for a moment to think of this. This is the boundary line. So when x is equal to 4, what's y equal to? 4. And what did you just do? You found another point for 4. Don't pick 10, right? Don't pick something high because then it's like going to be harder to graph. 4, 4 is good. 5, 5, 2, 2, anything you want. Anything you would let x equal to, that's what y would have been as well. Okay? Just be careful that sometimes you'll have y is greater than negative x. So then the line you're thinking of is y is equal to negative x. So when x is equal to 4, y would have been negative 4. So watch out for that. Okay, so y and x. Okay, you put that down. So let's graph the, let's graph, I skipped a few things here because of this, right? So can we just go like this? Where is it going to be a dashed or solid? It's going to be dashed, right? The true region is above because it's greater than, and so we're going to shade below. Very important. I skipped. So this is a little different. It's a different scenario, right? But from time to time, you're going to get one of those. So let's graph this one first. 6, 0, 6, 0, and 0, 3, right there. Let's go ahead and graph that. We expected it to go down, right? Because our slope is negative. So this will actually do that. So I'm just going to go dashed on there. I know I told you to enter this into your calculator first, right? That's usually a very good idea. But I know that my other line is going to go here. I know it. It's going to go through the origin, so I'm not too worried about it not fitting. So this is the line x plus 2y is less than 6. And then the other one is the one that goes through 0. And we came up with 4, 4, right? 4, 4. So if you had picked 5, 5, it would have been 5, 5. But you think you should see that it's still going to go through it anyways. Okay? So this is dashed as well. Make sure you extend it because you're just finding 2 points on it. This is the line x minus y is less than 0 or x is less than y. You pick whichever one, they're all the same, right? And now let's shade. The first line we shade above, see? It's very important to reference that. So you go to your first line and you shade. Nice and lightly, okay? There we go. And the other one, we told ourselves to shade below. So you take the other line and you just make sure you shade below that. Okay. So you've gotten rid of all the false regions, right? And so this is your solution region. Let's go ahead and find the POI, point of intersection. There's only one, right? It's where the lines meet. So go ahead and enter that. Negative 1/2, x plus 3. And the other one is just x. Okay. And then you graph it. Second trace 5. And that's 2, 2, which it does look like it, right? It should at least be very close on your graph, okay? So second trace 5, and the point for now there's only one. Soon there'll be 2 or more, right? Up to 3. Word problems might have even more, but a lot of them are easy to find, okay? So we'll just make sure that this is right, POI. Just label it like that. That's good enough. So that's 2, 2. So now my question is negative 12, 7? So negative 12 would be somewhere over here. 7, would that be a solution to the system? And it looks as though it is, right? But we're going to check for sure. So negative 12 plus 2y, is that less than 6? That's what we're going to ask ourselves. Okay, so negative 12 plus 14, is that less than 6? And this actually is 2 is less than 6. That's true. So far, so good. Then you use the other one. The other one, if I go back to the original, because most likely you're not going to graph it when I ask you to do this to check for a solution. I just happen to do it at the same time so you can see it. But if I use this one, right, it's saying that x, which is negative 12, is less than y, which is 7, right? This is also true, right? Therefore, it is a solution to the system. That's how it goes. All right, so I'm going to ask you to try page 31. It's a vertical line. I showed you how to graph vertical lines, right? 9, 9, 9, 9, 9, 9, 9, 9, 9 nines, and then bracket. If not, I can help you with that. Or Jalen figured out another way. So if you remember that, go see Jalen. and page 33 as well. So 31 and 33, you should be able to do at least one today. Okay, at least one. You want to start to be fast, like really efficient. How's that? Efficient. You should be able to know what needs to be done so you're not losing time because you're going to need it. Once you're done, if you want more, I'm actually sending you to the textbook. Textbook has 2, 4, 5, 7. However, the textbook doesn't use reverse shading, so watch out for that. But your solution region should be the same as theirs, okay? Except for you use reverse shading. So page 31, 33 today, I'll just give you a quick review on how to graph a vertical. This is how you do it. You put 9 nines in. You can do more if you want. It doesn't matter. Then you go bracket. If you want the line x is equal to plus 4 to be graphed, you want to go x minus 4. You do the exact opposite. And then when you graph it, it's going to graph it right there. If you want the line minus 4 to be graphed, then you would do plus 4, and then it's going to graph it right there, negative 4. So it's always the opposite. I don't know if you want to add this to your study sheet to make sure you know how to do it, because on a test or a quiz, I cannot help you with that. So then you're going to be on your own, all right? And I will post the key to this and the 33 shortly.